Welcome back to our grade 10 maths lessons. I'm Miss Awinup, your maths teacher. In our last lesson, we closed off on logarithms, okay? Today's lesson, we are moving on to a new topic, and that topic is surds. All right, surds. Now, this term is just a fancy way of referring to irrational numbers that are represented with a radical sign. All right. So surds, good example of surd. Now remember, the difference here is they represent irrational numbers. Now we looked at irrational numbers already in grade 9. You should know that irrational numbers are numbers that cannot be represented in the form a over b. All right, or as a fraction. This number being a whole number and this one being a whole number, okay? Positive whole integers. Now, examples of surds would be numbers such as √2, okay, or √7, okay? Other numbers, you should already work out what other numbers fall into surds, okay? Now, numbers that are not, not surds. Numbers that aren't, all right? That aren't surds are numbers such as √4, √16, or another one, cube root of 125. Why? Because the root of 4 is 2, okay? The root of 16 is 4, and the cube root of 125 is 5, okay? Whereas these numbers, like the root of 2 is 1.414, and on and on and on, okay? Irrational numbers are numbers that do not terminate. That means there are so many decimal places, there are so many numbers after the decimal point. Okay, so they are non-terminating. So here you can tell the difference between a surd and numbers that are not surds. Surds are represented, or numbers, irrational numbers that are presented as radicals or in a root sign or symbol. Okay, now, in today's lesson, we are going to simplify surds. Okay, how do we simplify surds? We are going to look at a couple of examples, and through these examples, we will see how to do that. Okay, now, let's have a look at an example, very simple one. Okay, let's see. Square root of 32. Now, how are we going to simplify this? The main aim here, okay, what's the aim? Find two factors of 32. Okay, two factors of 32. One factor has to be a perfect square, all right, with another number. Okay, so if you look at 32, and you find two factors that will give us a product of 32. Remember, that perfect square needs to be the highest possible number that you can find so that it makes simplifying easy. Okay? So what we do to simplify is we're trying to reduce the number in the radical sign to its simplest form. Okay? Reducing this number to its simplest form. All right? So factors of 32 will include 8 and 4. 4 is a perfect square, all right? Then you have 16 and 2, all right? And then, of course, 32 and 1. But these two numbers have perfect squares, or these pairs of factors. And the highest possible square number is 16. So, in order to reduce square root of 32, we are going to rewrite this as square root of 16 times 2. Okay, so one number being a perfect square and the other factor. All right, now we can separate these two. Square root of 16 times square root of 2. All right, square root of 16 is 4, multiplied by root 2 is 2. Okay, so we have reduced square root of 32 to its simplest form, which is 4 root 2. All right, now let's try out another example. This time let's get a bigger number and see how we can simplify this number. All right, let's have a look at, all right, example number 2. We have square root of 405. 405. And I repeat here, the aim is to find the highest square number so that reducing of this radical here will be made easier. Okay, so let's look at the factors of 405. We have factors like 9 and 45. Okay, we also have 135 and 3. And we also have factors of 81 and 5. Okay, now 9 and 45, this square number is too small. Okay, 135 and 3, none of these numbers are square numbers. And you look at this pair of factors, 81 is a square number. Okay, so the better choice would be 81 and 5. So root of 405 is equal to 81 times 5 under the root sign. Okay, then we break it up into two separate roots. So root 81 times root 5 is equal to square root of 81 is 9, and multiplied by root 5 is root 5. Okay, so we have reduced square root of 405 to its simplest terms, which is 9 root 5. Okay, we cannot simplify this any further unless you are using a calculator and you are asked to give the decimal equivalent of this. Okay, equivalent because these are irrational numbers and you have so many decimals, decimal places to consider before you give an answer. Okay, so for accuracy's sake, we leave the answer as it is. Okay, now I hope you've learned a little bit. This is a very brief introduction on differentiating between surds and numbers that are not surds, okay, and simplifying surds. In our next lesson, we are going to look at how to add and subtract surds, okay. I hope you've learned something new. I'll see you in our next lesson.